So yesterday we were able to do the UART communication. So we discussed about UART communications, and also we have seen the ITC one, ITC connections, right? So and then we try to do this. Okay. So I have my designer circuit. So circuit0.io. So this will help me to design any kind of circuits which are available for on this year. Right. So to any parameters, sorry, so to you want to do it, we can do that. So here in this case, I take my Raspberry Pi, right? So and I want to connect something called the MPU 6050 and then do the work here. Right? What I'll do is I'll try to go with the MPU 6050, connect it and try to click on add. So what it does is it's going to show me how to do the connections part. Okay, so pretty simple and easy. And then I'll go with GPS and then I try to add a GPS chip. Right. So the one which we have tried both, right? So yesterday. So this is all about the designing part. So we can use this circuit0.io. So for designing purposes. Right. So apart from this, what they do is they give a sample code for you. So sample code for you. So wherein you can start working from here onwards. Right. So this is all about a sample code which has been given. But on internet we have a lot of resources. We can try use them as well. So it shouldn't be a problem. Here in this case, code.py is the one, and the libraries which are related to the code, right? So for example, let's say if you are trying to look into the data about MPU 650, how you are trying to access and all, right? We have certain methods which are available here. We can use those methods, right? All these things are being designed and being used, right? So you can try all of those codes. Right. So you're trying to use .cpp file, .cpp I2C dev. I2C dev is nothing but which is with respect to the MPU 6050. MPU 6050 will use the I2C connectivity. All right. So that's the reason we are having both I2C dev as well as MPU 6050. All right. Both the files which are available for us to help doing that particular job in our case. All right. So this is the designing part. All right, so we are done with this, and let me add the GPS chip also. If I go ahead and do this, so it will automatically add those particular files because the wires also, right? So this is with respect to the RX will go to the TX of the board, all right? RX of the GPS will go to TX of this particular Raspberry Pi. Why? Because so if the other one is talking and this one is talking, so TX and TX are being connected, there'll be no exchange of data. There's a collision of data will be done. All right. So when GPS is sending the data, Raspberry Pi should receive it. That's the reason we are connecting a crisscross connection here. All right. So we are trying to do the job. So RX of that GPS chip is connected to TX of Raspberry Pi, and TX of GPS chip is connected to RX of the Raspberry Pi. So that we'll have a effective communication between the chip and these things. Right. So this is all about the physical part, but when you come to the coding, right? So we have seen that yesterday. So let me open that. Uh, Secure basics. So give me a second, guys. I'll try to find that. GPS, Python, Raspberry Pi, electronic wings. So this is the best source which I have found on internet, so which will help us to do the coding part now. So GPS chip, right? So we are trying to connect the one. So TX of this is connected to RX of the GPS chip. So we can try that, and then this is a coding part, guys. Right. So let's take this code and try to save it on our local file, and then we'll try to move this into the Raspberry Pi and try to do the work. All right. So I'll take a new tab and paste all the code and keep this for myself. And then I'll go with the accelerometer also. So the same thing. I'll try to copy the code. Alright. So our friend says the Raspberry Pi is available on 1.46. So is that visible, guys? SSH pi at the rate 192.168.1.40. Or 40, 46, right? Yeah. So it will ask you for the confirmation. Yes. Give the password. So password, I think you know, guys. So it's a capital P at the rate SSW0RD. Right. So sudo su clear. And so I'm inside my network. So let me hit Python and then check if it is available. Yes, it is. I'm gonna come back. Control D. All right. So it's available. So GPS connect చేశారా? Connected, huh? Yeah, okay. So here in this case, we are trying to connect the GPS interface and then we are trying to do the job. So let him do the work. So and then we'll try to execute this button. So meanwhile, what we do is we just copy that code and try to create a file. Okay. It's done. Okay, thank you. Copy this. How do we use it? So we can use nano editor and then so gps.py and then paste all the content. All right, so done. All code is available here. Okay, Control X, Shift Y, which will save me the file. So Python, and then we go with gps.py. Okay, so what it does, it's shouting at me saying that so and so dev is not available. So let me go ahead and check on which particular thing it is available. So let's tag LRT and then do this work, and I will try to check what other things are available. So it is available on AM0, all right? So I'm gonna copy that. I'm gonna go back AMA0, right? Where are we trying to connect? So let me go back. Yes, here it is. So AMA0, right? So we've done that. So Control X, Shift Y, and then okay, let's hit this. So it says some device report readiness to read, but return no data. Okay, so device is connected, guys, but here the problem is we are indoor, so we are inside the room, so we are unable to reach the satellite. So this part of code is ready for us. We can take the chip outside, we'll get the coordinates for sure. Okay, so we can try that. So is MPU650 connected? So just let me know when it is done, buddy.
It's not suitable for Windows.
Not suitable for Windows, so we cannot do that. So this is especially for the outdoor purposes, right? So if you want to get it for indoor, then we need to get a bigger antenna. So antenna size will increase on something like this. So generally, like the GPS chip, what you see is very small one. The size of antenna and reception is very less. So you need an open air for that, especially when you're tracking, right? So you need open air.
So for vehicle tracking system, we can be able to see.
Yes, we can do that.
Because most of the time it is like outside.
Yeah. So mostly like this is used for the asset tracking, like even the shipment tracking, mobiles, or also, and even for when you're trying for any movements, goods tracking. It's a vehicle tracking. So especially when you're talking about Uber or some. So recently we got a requirement from one of the Orissa government, right? So wherein they want to track their all the buses which are available there. So where exactly they are, and they're trying to do that. Even Vizag also. So AP government. So they are trying to look at all the GPS paths, right, which is so this GPS chip is exactly will give you the exact accurate information, which will help you a lot. All right, so this package is done. So let me go ahead and do the other one also. All right, so for example, let's say, let me take the acceleration part. So acceleration part, right? So let me take the other code and create the file meanwhile. So before we have the connections and everything is ready. So I'll try to copy this. So again, nano. Yes.
So we started
Okay. What's happening?
power cable problem.
Power cable issues. Okay. Okay. There I got some disconnections. That's fine. Let me terminate. Let me know when it is up, buddy. So there's a internal update. So update going on. So that's the reason it got disconnected. Let me go ahead and restart this.
It's connected.
Yes, got it. All right. Okay, sudo su and nano. So MPU py. So I'll go with this.
Here also we need to change the.
Yes, sir. No, serial port is not needed here, but we have a different thing. So we need to look into something called address. Right. So since we are, when you talk about the ITC communications, right, it is based on the pure address of the slave. Right. So yesterday I was explaining you. So multiple masters can talk to multiple slaves, wherein this multiple slaves will have addresses, and master will request that slave, and then slave will respond back with the data. Right. So in this case, yes, we are going with the masters, but we have to do something called I2C direct. I2C direct. All right. So detect. Sorry. So we need to go ahead and use this one. So to figure out whether our sensor is connected or not. So we need to use this command, guys. I2C detect TAC Y and 1, which will help you to do the job. So I'm gonna issue this command. If my sensor is fine, so it will show me the address of it. So 68 is the address. All right. So yesterday we have seen through the PDF files, all right, on all of that. So from PDF file we are able to pick up that particular address. So this is the address. So once you are able to connect the slave to a master, right? So if I issue this command on the Raspberry Pi, I'll get the address. Right? So I got the address. That is all fine. And then so next thing is I need to run that particular Python file. All right. So Python and then header. So some IO issue is that, so that says address. All right. So let me go ahead and check that address. You'll get errors for sure. So, but you need to figure out them and then close that. So X68. Address is correct only. Remote URL.
Yeah, we didn't enable remote GPS.
I don't think so. So I already done it as p.config. So if you have any issues, so come down here. I to see. Yes, it is enabled. It's already enabled. So this check we have already done it, right? So last time. So let's say serial. Yes, it is. So normally sometimes. Okay. All good. So it is something different. Just okay. So let me go ahead and hit this again and try to fix that. Okay. So line number 63, data read, acceleration, X out. So buddy, can you change the sensor? I think it is unable to read the data. So here we are able to figure out the device, but when you are trying to reach the internal registers, it is not allowing me. So maybe it could be an issue with the sensor. So let me go ahead and run this I2C detect. Yes, it is available. So let me go ahead and hit this one. Yes. Okay. We are getting the data. All right. So twist it, buddy. So left, right, something like that. So you can see he is twisting it. So we are getting the different data in this case. All right. So you're going to combine this with the other source, right? So let's say GPS, right? So with this particular MP6050, you will be able to detect whether the bike has fallen or car has met with an accident, something like this. All right. So and with the GPS coordinates, what you can do is you can pick that GPS coordinates and send it as an URL or an SMS or something else into a different place or into the cloud, saying that so and so at so and so place, this guy has an emergency. So you need to address that particular data. Okay. So you can combine sensors and you can meet a requirement like this. Right? So what I want you guys to do it is, so there's an final thing that you need to do. So as a final project, so you will have two different gyro sensors, right? So gyro sensors, one in the front part, one is the back wheel part. So when someone is trying to do any stunts, right? Normally what you do is, so your the front wheel data and back wheel data will be different. When bike is going in a straight line, yes it is. When it's trying to twist, right, it will normally does the regular work because both the sensors will generate the same data. But if someone is trying to do the stunts or some rash driving, something like this, if he's trying to twist the bike in between, something like that, right? So all these actions can be captured by these two sensors. You guys can work on that, and then you can just take a decision based on that particular data. Okay, you can do that particular job. Okay, so that is one assignment. So you can try doing that particular job. Okay, and then so what we have done, so we are done with the acceleration part. So similarly, we have something called magnetometer. All right. So this magnetometer, what it does is it's gonna generate XYZ acceleration values. All right. So here in MP6050, you are able to see all those values, just like how you're going to see all the gyroscopic as well as accelerometer. But in this case, we can get the accelerometer values alone. So this is more of like, so we are having the analog values directly available for you. So normally we can connect it straight away. So SL and SD and then try to do this job and we can get the values. All right. So magnetometer is for a different purpose. We are not including that. But if you want to be used, yes, you can try using that. Okay. So and we are having something called DHT11. So this is a temperature sensor wherein you can connect this to any GPIO pin and then get the data. Did we do this experiment? DHT11? Yes, we did that, right? So not directly to the Raspberry, I guess. We are connected to a different node MCU and then we tried this. So we can try this particular job also like this. The values will be like this: temperature and humidity. You will get the values like this. All right. So the actual catch, what we are trying to do here is you're going to talk to. So in Raspberry Pi, you're going to include your machine learning code. Right. The very best part here. You're going to write the machine learning code on Raspberry Pi. You're going to run those codes, whatever you're trying to do on the Raspberry Pi. Take some actions. For example, when you take an action like, so let's say robot move forward. So when it is move forward, I want to do the wheel of 4 rotations. I want to do the 4 wheel rotations. That instructions, if you send move forward, so on IoT device, what I do is I capture that instruction and I'll try to run motor for 4 times and do the move left. Then I'll try to twist the axle and then try to move it to the left. All right. So and then take 6 steps forward, something like. So whatever you would be taking that decisions. So machine learning will be taking that decisions. For example, let's say you're trying to capture the data from the camera and you're taking a decisions. All right. I2C, through I2C, you can talk to another chip. All right. That another chip is nothing but an Arduino file, Arduino data. And then on Arduino, we are going to control the wheels. Got it? So similar way how we have done it here. So let me show you that. Yeah, in MP6050. So here you have connected SCL and SDA, right? All right. So SCL and SDA here. So the same thing can be connected here. Instead of this sensor, I can connect my Arduino board, and that Arduino board will do the actions for you. All right. This is where the AI and IoT integration comes into picture. Got it? So you're going to do this job. All right. So you're going to do this job. You're trying to pick some value data. You're going to do the same way. All right. So can't I connect the MP6050 along with the Arduino boards? Yes, I can do that. In the other case, Arduino is acting as a slave for you. All right. So Raspberry Pi will act as a master for you. So master and slave communications will be taught right? So we'll be taught soon, so that how we are trying to send the instructions from one place to another place is important for you. Okay, so as you are doing the machine learning part, yes, you're going to do that job. Okay, so any questions here?
So the information, the sensors, why we use only camera right here or anything else? So
It's up to you guys. So what do you want to use? So if it is camera, yes, you can use camera. So are you going to use the USB based camera or something else? What is that? So then I need to give the code with respect to that USB base. All right. So that's that. If you give me that requirement, I'll try to work on that. I'll try to give that. So the way what we have run is UART is nothing but USB communications. Whatever you're trying to do, right? The UART communications, what we have done with respect to GPS. The same thing can be done on the same USB connector. So when you're trying to connect the USB camera and Wi-Fi camera, and then you're trying to access that values, the same way what we are trying to. Yes, we can use that. Through IP address, we can reach that IP cams and then we can get the data. If you want to do work on these particular things, we'll try to figure out the IP of this, and then we'll try to get that data. Shouldn't be a problem for us. But we need to check whether that is connected to IP or not. So we need to do that. So any questions, folks? All right. So and the Raspberry Pi and Arduino I2C communications using Python. So we are going to use Python for this, and then we try to do the job. So the connectivity will be like this, guys. So if you see it, so this is an old board. Let me pick up the latest one. Right. So you can see it here, right? So the RX and TX are connected to the RX and TX of the Raspberry Pi. All right. So we can try using this particular thing, and SCL and SDA, which are connected here. You can try that, or you can try this way also. So we have the alternative pins. All right. So whatever actions you are trying to send, right? So it will be sending as part of the IDC communications, and you would be doing that particular job. So how the code is, right? So it is pretty simple, straightforward, and so on Python, so you would be sending the data. So for example, here it is. So from SM bus, and you're going to get the address of the slave. So this is like 0x08x 0x8, and on the other side sketch, right? I'm going to set this particular Arduino as a slave. All right. So here is it acts as a slave. So here you can see the same address 0x8, and Python is acting as a master, and it is trying to send some data, right? So 0x8 is the address, so it is trying to connect that, and it is trying to send the data, right? So 0x1 is nothing but switching it on. 0x0 is nothing but switching it off. All right. We are trying to do this particular job in this case. All right. So and when you try to send this data here 0x1 or 0x0, right, that data is being received here. You can see that. All right. So on setup, we are trying to receive the data, right? Whatever data you are trying to receive, all right, we're trying to put that into the LED. All right. So out is nothing but which will help you to put the data into out, and the function on receive function event. So whatever data you are trying to send will be written into digital write. Digital write is nothing but we are writing the value to the LED pin in this case. All right. So tomorrow I can write it for the motor. Like similarly, I can connect a motor and then write the data back. So this part you should know, guys. So this is the only part that this is one of the way, and the other way of doing it USB with UART. So that is also a different way of doing it. Right? We can try that. So this is one link, guys. I'm gonna share this. Please have a look at this. So it will help you to get a clear understanding on that. Well, Okay, so any other questions here? Clear? Am I too fast? Is that clear? And then, so we have multiple steps that we can do. So even this will help you to do the job. All right. So do the job. So not just I2C, I can have an UART communications serial. All right. So the serial communication is nothing but I'm going to connect the USB of the Raspberry Pi into the board. Right. I'm going to send instructions through serial also, which is also possible. So
Is the speed differs?
yes, speed does differ because serial is very fast. In case of I2C, we are searching for the address, we are sending the instructions. It is a double task. But when you consider multiple slaves, multiple data to be controlled, right? So that is better. I2C is better. When you are trying to control a single slave, this is better. Serial is better. All right, so you are directly connecting this particular USB serial from this USB into the USB of it, and then we are trying to control it directly without any problem. Got it? Okay, guys. So this is another one.
USB
Hmm.
and the serial are the same thing, or USB some other protocol and the
USB
serial.
serial and USB are same thing. So USB is a generic term. Yes, buddy. Serial is the technical term. All right. UART is also belongs to the same thing. UART communications is a communication type. So UART, serial, USB, all are all three are same. But I2C is different. I2C is different, wherein we are trying to have this master and slave, established master slave communications, wherein we are trying to. Okay. All right. So this is about the INO file. So if it is Python, yes, it is. And so this is as simple, very pretty simple code. We just need to read the serial and then print the data. So you just need to read that serial print and then read the data. So and on Python side, we are going to send the data, right? So serial.readline, we are going to read those data in this case. So either ways, two-way communication is possible in either ways, right? So on slave, I2C as well in USB UART also. Both the things are possible, right? So these two are the codes. So what I want is, so what do you want to do? From here, what do you want to do? So I'm going to give two assignments. One is with respect to the agriculture. The second one is with respect to the accident detection. All right. So or the rash driving pattern detection. So you need to work on that area. Right. So we can generate the data and give it to you. So from here onwards, you're going to pick up that data and do the. All right. So any questions? So we're going to set this up by tomorrow. We are going to set this complete thing and then we're going to give it to you. So you need to work on the data. Take the data and use the sensors. You use a small toy bike or anything. Even a small stick is also good. Right? So two sticks which will help you to do the job. All right? So when you bring it up and then you bring it down. All right. So how do you normally take the data? So is that through a flat file or flat file? A text pad is CSV, is it? Okay. So then you need to know how to generate a CSV file from our applications. So that is good. Okay, on Raspberry Pi from Python, I think you can generate, I think we can generate a CSV file. That shouldn't be a problem. So,
In Python, any file we can do.
okay, so,
Any format.
okay. Generally, what do you use? So CSV, is it? Okay. So JSON format is accepted. And things. So because JSON is way more flexible for us, so we can generate that easy. Okay.
And we can write in CSV also. Just CSV library, we have to use.
Yes, yes, so that is possible. Yeah, you can try. So the sensors will generate data and push it to the Raspberry Pi. So once the data are received by the Raspberry Pi, so we are going to save them in a flat file, and then you can take whenever you want those files. Or if you want to push this to the cloud, we can try pushing this to the cloud using S3 bucket, something like that. So you're well versed with the Amazon AWS, right? Not really. Okay. So you want to save it in a local machine, something like that. Okay. That shouldn't be a problem. So we can pick the data from Raspberry Pi and push it to your local machines. So if you try to set up some FTP server, something like that, we can try to push that to your local machines, and we can try to save that. Shouldn't be a problem. All right, guys. So any other questions here? We'll try. We'll try to set this serial part, and then what I'll do is I have this particular motor base with me at home. Right. I'll try to get it tomorrow. We'll try to configure Raspberry Pi and then Arduino as a serial communications, and then we're going to do that particular serial communication. We're going to exchange that data, and once I get the data, so I'll try to set those actions to do some actions on the wheel motors and all. So we'll try to do that. So rest I'll give that base to you, so you can work on from there onwards. Right? So how to move forward, backward. Right? So based on the camera, so data. So
You say camera on the
yes,
device, right?
on the
This
device,
camera.
not on this device, not on this. We'll have, yeah, we'll what we'll do is, so we'll generate a small LED. Right, so wherein we have the red and green and yellow LEDs. Right, so these LEDs can be controlled using our Arduino boards, the additional Arduino boards.
You can
Wherein
use
based,
for phone also.
yes, yes, even the phone is also good. So or any red, green, and yellow lights should be good. We're going to show that based on that lights, it is going to detect, and then you can
Do you
work
have
on.
any other sensors apart from camera to detect the? Mainly we need the object detection, right?
Yes, yes.
And then
So we have, see, obstacle detection, we have something called ultrasonic sensors. So we have those sensors. So when an obstacle is very nearby, somewhere around so 10 centimeters. So 100 to 10, see, the range of ultrasonics is from 10 to 100 centimeters. So I can restrict, so I can identify easily an object restriction. And if it is closing nearby, I can stop the vehicle also. That all those alerts can be done at my side.
we'll try
So
camera first.
yes,
Then we can.
yeah. So what you can, so these two things, if you can do it, so we can build an autonomous cars, something like this. We are going to show that.
That means based on the color of the light, whether it has to move or stop.
Yes, yes, exactly. So we can install it in our car, in our regular car, so we can go through the traffic signals. We'll try to capture that data. So even that also we'll try to do a real-time use case.
At real time with the camera, I think it will be problem with particular angle we have to.
Yes, so we're going to focus that more on that area.
So automatic the camera movement also has to be
Has to be
controlled
controlled. Okay. Yes.
by using motor.
That we can add so much. So let's first do the basic part. Then slowly we'll add it and make it more dynamic. Something
Color
like
detection already we did it.
that. Okay, yeah. Okay.
Only red color and yellow color we did it.
Oh, is it? Okay, that's nice. So what sensor did you use? Yeah?
Camera,
Camera itself. Okay. Camera.
OpenCV.
Camera it is possible. Yeah. OpenCV, I think you are well versed with those. We can work on this. So maybe like from tomorrow or day after tomorrow onwards, we'll work on the POC part. We'll try to build the POC. So this week at least one POC. Next week another POC. So we'll try to wrap it this for this. All right. So any questions you have? All right. We'll set these things up and then give it to you. You can start working on from there onwards. All right. So with that, I'm closing my class. So We'll catch up tomorrow on the regular basis. Thank you.